students, today's lesson is on operations in scientific notation. We're going to start with addition and subtraction. We're going to deal with addition and subtraction problems in the same way. Step one is to look to see, are those numbers in scientific notation written in the same power? So are they both times 10 to the fifth power, or are they both times 10 to the negative third power? Whatever that power is, if they're the same, we can just add or subtract the factors and keep the power as written. If the numbers are written in different powers of 10, we need to rewrite one of those numbers so that they are in the same power of 10, and then we can go back to the first bullet point here. So let's look at an example. This first problem asks us to add two numbers written in scientific notation, and they're both times 10 to the third power. So what we can do is just add the factors. So I'm going to rewrite this as 4.6 plus 8.72, and this whole sum times 10 to the third power. So now we'll add these together. It's 13.32 times 10 to the third power. And then we just have to look to see if is it still written in scientific notation. And in this case, it's not, because 13.32 is greater than 10. So I need to rewrite this as 1.332 times 10 to the fourth power. Now, if we think about this, if we're adding two positive numbers, it is going to get larger. So it's okay that our exponent got larger as well. We wouldn't expect that our exponent would get smaller if we're adding two positive integers. Here we have a subtraction example. We have 3.5 times 10 to the negative 2, and we're subtracting 6.6 times 10 to the negative 3. Now remember, when we're thinking about negative exponents, the larger the absolute value of that negative exponent is, the smaller the number is. So this first number is larger, and the second number is smaller. So we should have a positive difference. But right now, we need to think about rewriting, and we'll rewrite this second number in the power of negative 2. So I'm going to rewrite this as 3.5 times 10 to the negative 2. And we're going to subtract. I want to change this to 10 to the negative 2. So I want this to be larger by a power of 10, which means that this factor will need to get smaller by a power of 10. Divide by 10. So that's 0.66 times 10 to the negative 2. So it's not written in correct scientific notation anymore, but now I can subtract. So I'm going to do 3.5 minus 0.66, and that difference times 10 to the negative 2. So when I do that, that's 2.84 times 10 to the negative 2. We need to look to see, is it still written in scientific notation? And it is. Most of the time when we're subtracting a number that's a power of 10 smaller, it's still going to be written in the correct power of 10. All right. So now we're going to look at multiplying and dividing numbers in scientific notation. This is way different than adding and subtracting. When we multiply or divide numbers written in scientific notation, we're going to multiply or divide the factors together, and then we will multiply or divide those powers of 10 separately from that. When we think about this, if we're multiplying two really big numbers, our product gets really, really big, really fast. If we're multiplying two really small numbers, that number gets way, way smaller. So we're going to see that those powers of 10 are really going to have an impact here. So let's look at this example where we're multiplying 3 times 10 to the negative fifth and 5 times 10 to the negative second. So this is really just all straight multiplication, right? So we could think about the commutative property and the associative property tells us we can move these around and group them however we want. So we're going to change this around and say we want 3 times 5 together, and then we want 10 to the negative fifth times 10 to the negative 2 grouped together. So 3 times 5 is 15. And we know that 10 to the negative fifth times 10 to the negative second is 10 to the negative seventh. Okay, so we have multiplied these numbers together. Now we just need to make sure it's still in scientific notation. 15 is too big, So I need to rewrite this as 1.5. And remember that if we're dividing by 10 from this factor, we need to multiply by 10 in this factor, which means make it larger, which in this case means less negative. So it goes from -7 to -6. All right, let's go ahead and try a division example. Here we have 1.5 times 10 to the -8th divided by 6 times 10 to the 7th. So we're going to write this as 1.5 divided by 6, and we're going to multiply that by 10 to the -8th divided by 10 to the 7th. So 1.5 divided by 6 is 0.25. And then 10 to the -8th divided by 10 to the 7th is 10 to the -8 minus 7. So that's 10 to the -15th power. Now we just need to rewrite this so that it's in scientific notation. 0.25 is too small, so we need to rewrite that as 2.5. We've multiplied by 10 here. We made this larger, so we need to make this part smaller. So that's 10 to the -16. All right, one more example. Here we have the diameter of the sun is 1,400,000 kilometers, and the diameter of the earth is 1.28 times 10 to the 4th kilometer. So we want to know how many times greater is the diameter of the sun than the diameter of the earth. So that's dividing this diameter by this diameter. So let's go ahead and rewrite the diameter of the sun in scientific notation. That's 1.4 times 10 to the 1, 2, 3, 4, 5, 6. 1.4 times 10 to the 6th, and we're going to divide that by 1.28 times 10 to the 4th. Okay, so let's go ahead and separate out the factors from the power of 10. So I'm going to say that's 1.4 divided by 1.28 times 10 to the 6th over 10 to the 4th. So 1.4 divided by 1.28 is 1.09375. And then 10 to the 6th divided by 10 to the 4th is 10 to the 6 minus 4, so that's 10 to the 2nd power. Okay, and this is written in correct scientific notation. If we want to, we can think of that in standard form. It's about 109 times the size. Okay, that is it. Let's go ahead and try a few on your own. I'll see you soon.